All right, so we're going to be talking a little bit more about quadratics, but in the sense of graphing a system of equations. Okay, and the very first way they tell us to do it is graphing by solve by graphing. So let me do that really quick. Let me grab my thing here. Okay, so let's go to Desmos. Okay, so the way we graph a system in Desmos is we put one equation in one line and we put another equation in another line. So let's do that really quick. So x squared minus 4x plus 1. That does not say x squared, does it? X squared. Okay, that's better. Okay, so x squared minus 4x plus 1. Ms. Johnson, I need to be very careful when I plug in stuff. And so this is x minus 3. And so there's your two things. Okay, so what do you think that they mean by solve the system and then it looks like this? This is the picture. What do you think my answers are? If this is the picture, what do you think the answer is? What do you think? What do you think is the most important part? You want to take a guess? Not the x-intercepts, just where the two, very good guess though. Yes, very good. Where they intersect or where they touch. Okay, so you're basically asking, where do these two things, what do they have in common? That's what they're asking. And you're like, oh, what do they have in common? Well, they have that point in common right there. And they have that point in common right there. Okay, so let me snap this really quick. Okay, right there. And so that's going to be my answer. My answer is, oops, I want to go here. So my answer is this. And then I'm going to go steal when you guys put it in the chat because that was good. So yeah, where they touch each other. So that's all I'm looking for is what do they have in common? So does that make sense? So this is the picture. Whenever you're graphing, do you see what I said? This is going to be kind of fast. So where they touch each other. So yeah, where they share. So our answers here are going to be 1, -2, and 4, 1. So those are my answers. So let me write those down. 1, -2, and 4, oops, not -1, just 1. That's it. There's your two answers. That's it. Everybody okay with that? And you guys are like, yeah, that's easy, Ms. Johnson. So then I would graph it here. And then they say to solve it algebraically. Then they say to solve it algebraically. So let's see. So what I'm going to do now is I'm going to use, if you remember, the ways that we could solve it were either substitution or elimination. And so some of you remember those, and I'll just tell you right now, elimination won't, well, actually elimination does work for this one, so I'll be quiet. Okay. So what I'll do is I'll take this, I'm going to actually snip it so I don't have to copy it. So I'm going to take this. I'm going to use substitution because that's kind of my favorite way. And then as soon as I show this to you, you guys will be like, oh yeah, I kind of remember this from either 8th grade or from last year in integrated 1. So one of the ways that you can solve it is by substitution. And substitution goes like this, right? You go, actually, I will be using elimination. I'll show you both ways. Sorry, I was a little fiddle-fatty. I don't know. I was going back and forth. So I'm going to use substitution first. So the way substitution works is you set one of the variables equal to that. And then because this equals this, then I can plug all of that into this. And some of you are thinking, Ms. Johnson, does it matter that it's y1 and y2? Well, not for our substitution, because all I'm trying to do is find where they intersect. So again, instead of writing y, I'm going to write x minus 3 here. So I write x, oops. I write x minus 3 equals to x squared minus 4x plus 1. Okay. And then you're like, okay, Ms. Johnson, how do we do this? Well, I'm going to scroll you back up all the way over here. If you notice, every single time that we solved one of these quadratics, what was always on one side? Here, here, and here. What was always on one of those sides? What do you guys think? Look at that. What was always on one side? Yes, they always equal to 0. And then, you know, Ms. Johnson makes fun of it because that equals to 0 makes it looks like a face. Yeah. So that means that one of these sides has to equal to 0, Ms. Johnson? Yes. And for me, I want to keep x squared positive. So I'm going to move everybody over to the right. So can you do that math really quick for me? Go ahead and do that math. So I want this equal to 0. So what I want is down here, 0 equals 2. So go ahead and do that math. I'm going to pause the video so you guys can try. Okay, so the way I'm going to do this is I'm going to, I'm going to solve this for 0, which sounds really funny. Basically, I want to move these guys over here. So that means I'm going to add 3, because then negative 3 plus 3 would be 0, right? And then I'm going to subtract x. And I'm going to do it at the same time because you can. Subtract x and subtract x. And then I'm left with x squared minus 5x plus 4. Okay. So I'm going to pause right now and show you what we just did, because right now we are at where we were a little bit ago in terms of this. Now you know how to solve this equation. So I'm going to pause right here. So what did we actually do? How did I get this equation right here? How did I get this equation? What did I do to get that equation? What did I do? Yeah, I substituted. Very good. I substituted. So what did you substitute? So again, Ms. Johnson, she uses this example all the time. So let's pretend that this is Ms. Johnson's sandwich. Okay, this is a sandwich and there's bacon on the sandwich. Ms. Johnson does not eat bacon unless it's turkey bacon, because then it's good. Sorry if you like the other kind of bacon, you haven't tried turkey bacon, you're missing out. Okay. So anyways, on the sandwich, I say, hey, is there any way that instead of putting bacon on my sandwich, can you put avocado instead? And they're like, sure, why not? So here, instead of putting bacon on my sandwich, they're going to put avocado instead. So here's my sandwich. There was the bacon. And instead they put avocado instead. So I substituted. That's why this method is called substitution. So was that difficult? No, you guys have seen this before. And if you haven't, that's okay. We're going to practice it. Oh no, we're doing jokes again. I don't know. Hold on. So from here, when we're right here, actually from here. So then I said, oh, this is a quadratic. In order for me to solve a quadratic, I have to make one side equal to 0. So I'm going to add 3. I'm going to subtract x to both sides. And therefore, this is equal to 0, right? And then this is a quadratic. So then I'm going to go back over here and I'm going to choose my favorite way. Am I going to use completing the square, quadratic formula, factoring? Which way are you going to solve it? And then you just solve it. Okay, so it'll give me, hopefully it'll get me 2 different x's, which we already know the answer. It's going to give me 2 different x's, right? So because it's going to give me 2 different x's, I should therefore have 2 different y's. I don't know. Okay. So with that being said, I'm going to have you pause again, and I want you to choose your favorite way. Factoring, completing the square. What's the other one? Quadratic formula. You can't use graphing because we already used graphing. right? So I want you to choose your favorite way and then solve it. Got it? All right. Okay, so I'm going to use factoring to solve this because I instantly can look at this and know it could be factored. So here, I'm going to, like, in my head, I'm doing that whole, like, you know, finding what two numbers multiply to get to 4, but add to get to -5. So that's -4 and -1, right? And then I'm doing this whole thing with x squared, -4x, -x plus 4, right? And then I'm seeing what's the biggest thing I could take out? It's x. And then x times what gives me x squared, and x minus 4 and x minus 1. So here's your two things. So x minus 4, x minus 1 equals to 0. Yes? Yeah. Perfect. Okay. So then my question becomes, what do I do now? What do I do now? What do I do now? What's the next step, guys? Very good, very good. So you're using the zero product property. Very good. They're also called x-intercepts. You all got the answer as x equals. So you guys separated this out. So it said x minus 4 equals 0 and x minus 1 equals to 0. Whenever you get this parentheses equal to 0, right? This times this equals to 0. Just think about, man, that was my favorite times tables when I was a third grader, right? Because 0 times anything is 0. So I'm going to make each of these equal to 0. Therefore, my answers are x equals to 4 and 1. Okay, x equals to 4 and 1. Okay, so you have to solve it for both of them have to be solved for x. So there's 4 and 1. And then if you notice here, what are your x's? 4 and 1. 4 and 1, right? So then, wait, Ms. Johnson, how do we get these y's? Anybody? Okay, now look at this, all that I've given you here. How would I find my y? How would I find my y? How would I find my y? Yeah, by substitution. Very good. So you're going to take your x and you're going to plug it into either one of these. Which one would you choose? Equation 1 or equation 2? Which one of these would you choose? Equation 1 or equation 2? I would too. I would choose equation 2 too, because I don't want to have to plug it into that mess, right? So let me just plug in. So if I have x is 4, what is my y? If I have x as 1, what is my y? And I'm just plugging into this equation here, right? So 4 minus 3 is 1. So that's 1 here. When x is 4, right? When x is 4, y is 1. When x is 1, y is -2. And if you notice, these are the same exact answers that you got over here, which is the same that you got over here, right? So all of this matches, and it should, right? All of this matches. So what's the moral of the story, Ms. Johnson? We solve by graphing it, and then reading the graph. It's not good enough to give me a graph without any like answers here. You had to know where they touched each other or where they intersected. Those are your solutions. Okay, here we substituted, and then we got to a point and we're like, wait a second, this is what we've been doing this whole time. Exactly. And then the last step is you just had to plug back in to find your y. So very, very good. The last step that I would definitely take is I would plug these back into both equations to make sure that they're true. Now, the reason why I do that, I've told you guys before, this is my favorite. Well, math is my favorite because I can always make sure that I'm right. All right. Thank you so much. Let's stop this video. Boop.